Question 8. The table shows values of variables v and p. These are the values of v and these are the values of p. So part 1. By plotting a suitable straight line graph, show that v and p are related by the equation p equals k v to the power of n, where k and n are constants. So first of all, we need to use the linearity law. So it's using logarithm. Log p is equal to log k plus log vn, since it's that multiplication of that. So log p is equals to log k plus n log v. Then we use these two logarithms to find the value and create a table. So it's log v and log p. So for log 10 is equals to 1.00, so that we can make it everything to decimal places. Log 95 is 1.98, since it's rounded off to 2 decimal places. Then the logarithm of 550 is 1.70. The logarithm of 8.5 is 0.93. The logarithm of 100 is 2.00. The logarithm of 3 is 0.48. And finally, the logarithm of 200 is 2.30. And the logarithm of 1.1 is 0.04. After that, we can then finally put in the values in a graph. So the x-axis is log v and the y-axis is log p. For our x-axis, we make 2 centimeters for 1. So it's 1, 2, and 3. For log p, this is 0.5, 1, 1.5, 2, 2.5. So for log v, 1, and log p is 1.98. So it's better to use the pencil so that you can erase it. 1 is here, 1.98 is around here. Then 1.7 is this one. So it's 0.93, so it's around here. And for 2 is 0.48, it's around here. And for 2.3, which is this one, is 0.04, which is here. Then we can then draw a straight line to see that's the line. So for part 2, use your graph to find the value of n. To find the value of n, we must first use the equation log p equals log k that we have written before, which is plus n log v. You can see that this is the x and this is the y. So this must be the gradient, which is m, and this must be the y-intercept, which is c. So by finding the gradient, we must find it from the graph. So we take one point, like this one, and this one. So it's the axis one point 1.35 and 1.5 to 2 and 0.48. So m is y2 minus y1 over x2 minus x1. So it's 0.48 minus 1.5 minus 0.48 over 1.35 minus 2 is equals to minus 1.569, which will run off to minus 1.57. Part 3. The value of b when v equals 35. So we can insert v, so log 35 is equals to 1.544. So then we can go back to the graph and find 1.544. 3, 5, 5, 4, 4 is somewhere here. Then we draw dotted lines so that we can know where is the y, which is log b. So now we know it's around 1.15. So log b is 1.15. So p is equals to 10. We will use this one, 10 power of 1.15, which is equals to 14.125 equals to 14.1. In the marking scheme, we will get a mark for this statement over here, and then we will get another mark for plotting the suitable graph, and then we will get a total of and minus 1 for each error in points plotted. Then so we get 4 marks for the graph. And for part 2, we will get a mark for equating numerical gradient to n. So this is equals to gradient, and then find this the answer. And also for part 3, we will get a mark for the use of the substitution and the final answer from the graph.